Good afternoon. Hope your lunch was good. I'm Chris Bond, and I am the director at AWS EC2 for AWS Thinkbox. I was the founder of Thinkbox Software. I'm going to just briefly introduce myself so that you have an understanding of where I'm coming from, what I'm talking about. In the early 90s, I worked in broadcast and media, multimedia production. In 97, I started my own visual effects studio called Frantic Films. 2007, I sold that company, and later in 2010, I formed a company called Thinkbox Software. And Thinkbox Software's premise was to create tools for digital artists that we learned to help them facilitate projects based on things that we learned in production. So our primary tool at the time was called Deadline. In 2017, after helping thousands of customers launch huge render farms and their on-prem equipment and start moving towards cloud, we were acquired by AWS. And over that time, we've migrated a little bit. And what I can tell you is after 18 months of being acquired by AWS, you get this cool new logo. I'm here at AWS, and our mission is essentially to help digital artists and content creators build pipelines, whether it's on-premise, hybrid, or on AWS, and bring those tools to scale to their needs of today. So let me talk first about one of the key tenets of a production, and that is rendering. And I'm going to go over a couple of items here: rendering, storage. Later today, there's a workstation track. But all of those things sort of encompass a studio pipeline. So if we consider rendering, what we have here is a traditional hybrid rendering pipeline. So when we launched Deadline 10 last August, traditional on-prem infrastructure might look like this. You have a bunch of render nodes, you have an asset server, and you have some sort of database on-prem. With Deadline 10, we launched this infrastructure where you could connect all of this to your on-prem infrastructure over secure connection with assets, render nodes, and infrastructure on the cloud. So this shipped in August of last year, and since then we've had a lot of our clients moving and migrating their rendering pipeline to the cloud. And what I want to talk about is what we've learned over that time period, how it's happening, what's successful, what trends we're seeing, et cetera. So the first thing I'm going to talk about here is this concept of EC2 Spot on AWS. So I don't know if you're familiar with this, but I keep running into people that don't understand the difference between the instance types on cloud. So I'm going to talk about that right now. So on Amazon, we have essentially three different types of instances. We have on-demand instances, right? These are instances that are yours, that you pay for by the second, that you can scale up and down, and they're available at any time. Reserved instances are based on a commitment. So this is the kind of idea where, rather than buying equipment in your cold room or on-prem, you want to migrate to the cloud, have someone else manage all of it, but you want to be able to have a lower cost than on-demand. And so if you make a commitment to AWS, you can access these instances at a significant discount to on-demand prices. And now Spot, which is what we talk about rendering for a lot, all of this is all of our spare capacity at AWS. So these are instances that aren't being utilized by anybody else. And because we're able to sell them to you at a 90% off demand price, because they're available idle compute that we have. So we're essentially taking the compute that we aren't using, and we're selling it back to you for a super big discount. So the caveat, there's a couple of caveats, and I'll get into that. So the big advantage is it's low cost, 90% off on demand. You can scale really easily. They're easy to access. They're all over. They're in every availability zone around the world. You have a lot of flexibility. And one of the key questions is, like, how does the price change or fluctuate? So it changes very slowly over time based on the supply and demand of spare capacity. So we set that price. And there was a point where, and I'll get to this, where you used to bid against other people, and that doesn't happen anymore. So how it works is you essentially just request the capacity, pay the current rate, and when you need it, you use that capacity for rendering, bursts, or anything else, and when we need it, we'll just take it back. We'll give you a 2-minute warning. And this works really well for rendering because generally, your renders are going to be complete prior to this issue. And products like Deadline, our render farm manager, handle any issues without failure. So I'm going to jump ahead for a second here. I'm talking about what's new. This is the pricing that I was referring to. So prior to our announcement about the pricing change, so before we used to have a bidding program, and this caused a lot of confusion about how people would access these spot instances. And so they would bid on them, and a lot of people would just set the bid price, slightly below on demand, and they would get it for whatever availability they wanted. So the price fluctuated a lot. So people were concerned about how the price would change, and they didn't quite know how the spot market would fluctuate. And so they spent a lot of time and effort working through the spot market. And after the announcement, when we changed the price, you can see that the price has fluctuated very slowly. And this is based on our needs, not on the rest of the market. So you don't have to set a bid price anymore. You just get the lowest price that you want for spot. So how can you access EC2 Spot? And what new features are there? So the great thing is Deadline 10, out of the box, supports Spot directly. So if you're using Deadline on-prem to render, if you got your own render farm on-prem and you want to build a hybrid render farm for the cloud, you can scale up using Deadline, and it just uses Spot out of the box. It can show you the different prices in different regions, the different instance types, and you can just access them that way. If you want to access them yourself, there's easy API that do so. Run instances is an example of one of them. Because we don't have fluctuation in prices, it gets updated once per day, every 24 hours, very slow migratory changes. There's low predictable prices, and you don't have to worry about the price changing on you. And we've added new features, such as start, stop, and hibernate. And what those let you do is stop an instance, and the state will be recorded to whatever's on the disk will be recorded out, and you can start it up later. And hibernate actually pauses memory. So if you have a job that's a super long simulation and you're concerned about it getting interrupted, it'll actually get stored on disk, and it'll restart later when there's capacity. But let's talk about that capacity for a second. Interruptions usually don't happen. Now the whole premise of this is that this is our spare capacity that we can take back. So we can't promise you that it won't get interrupted. But the reality is that 95% of spot instances in the last 3 months only were stopped by the customer terminating the instance. They weren't stopped by a 2-minute warning or capacity demand. So here's an example of a customer, Passion Pictures. So they're based out of UK, and they have a traditional on-prem render farm, and they had additional projects come in. And normally, we call these sort of things like the rush, the 911 disasters, where you have this conflict. And you either have to outsource to another company, you have to say no to the customer. But in this case, what they did was they just embraced Deadline, very quickly spun up a cloud render farm, and scaled up their infrastructure. So without this, they couldn't have delivered in the time frame that they wanted to, and then, they, excuse me, they couldn't have delivered within the time frame and done the number of iterations they wanted. So this elastic scale is quite different than like forklifting in hundreds of machines to your on-prem and configuring them. Deadline can do that all automatically for you. So you can, within minutes, you can go from hundreds of machines to thousands. So I want to talk about some assumptions that we made when we first started on this journey. So when we first looked at some on-prem infrastructure, and this is an example of a sort of small to mid-sized studio, and how their on-prem rendering looked. And as you can see, there's a bunch of peaks here, and these are hours at the top. This is 24 hours. And they're waiting for their renders for these long periods of times. The blue is when the entire render queue is essentially blocked by those jobs, that nothing else is getting through. So these peak periods, we thought, when we first talked to customers, they said to us, we have 50 machines, 100 machines, 1,000 machines on-prem. We want to be able to scale to the cloud, but we think we're just going to do burst. We're going to take the peaks off this and just scale that up. So we thought, okay, well, our customers are going to scale up, and they're going to add, 50 machines or 100 machines, or if they have 1,000 on-prem, maybe 500 or something like that. But this turns out to be wrong. What's actually happened is customers are adding anywhere from 3 to 5 times to 10 times their on-prem infrastructure. And they're doing that because they want the data quicker. So if you look at this is a mock-up using that same data of essentially scaling the number of machines that the customer is using to get the jobs back faster, so they get them back within an hour or two. So what's happening is we've seen these customers again and again come to us and say, yeah, we're just going to burst. And then within a matter of weeks, a project comes in, they change their mind, and they say, oh, by the way, we're scaling up to 3,000 instances. We're using 126,000 cores. And the infrastructure is dwarfing their on-prem infrastructure. So we have an example of a customer that did a really big project. This is Micros Animation. So they're based out of France, and they were doing an animation project called Sherlock Gnomes. And they have a number of machines on-prem, fairly significant render farm. But the project demands and the schedule and the stories, like you can see how the productions want to delay all the time what decisions they make as long as possible. And so the fact is that a customer like this is able to scale up to over 170,000 instances and do 4.5 million compute hours on AWS with very little notice right at the end of the project and essentially do almost 90% of the rendering all on AWS. So I don't know how they would have done this on-prem otherwise, what shortcuts they would have made, what decisions, how they would have forklifted in the machines. It sort of boggles the mind, the idea of to scale up their infrastructure 10x in a short period of time. So they didn't use Deadline. They used their own render farm manager. But our team, because we're part of AWS, we're dedicated to ensuring that our customers get to the cloud and they have the capacity and scale and elasticity that they need. So we help them build a connection directly to Spot. So I'm bringing up storage now because when you think about it, if you have 50 machines on-prem and you're going to scale up to the cloud and add another 50, that makes sense, and you get that. But what happens when you have to go up 10x or go from 50 machines to 1,000? So we had a customer recently who had about, I think, 300 to 500 machines on-prem, because 300 dedicated, another couple hundred workstations they render on at night. And they scaled up and added 3,000 on the cloud to get their production done. And so when you think about that, you don't generally think about storage because you're in a position where, think about it this way. If you have 5 laptops in a room, and that's what you're working on with your favorite After Effects project or something, and you start using the cloud and you start doing more and taking on more projects and getting bigger, and you're suddenly like, oh, I can scale up 500 machines in a minute, right? It transforms how you work, how you think about the work, and when you say yes to the customer, but you don't think about the infrastructure. So I'm going to talk a bit about the Deadline 10 infrastructure and how we manage assets, and then I want to talk a bit about some of our partners. So in Deadline, an on-prem user will submit a job. We have something called an asset. This is our asset server. This is where you store your files, your dedicated server, your disks, whatever, on the machine. We get a list of those assets from within the Deadline submitter. So Deadline has a submitter for Maya, Max, and After Effects, all these different products. And so in Maya, Max, Nuke, and others, we can capture that list of assets. We can then see if those assets already exist on the cloud. And if they don't, we transfer them over a secure connection. And once those assets are on S3, when you spin up the instances to render the job, what we do is we copy the assets from S3 to a local EBS volume on every machine. So every machine gets the assets it needs to render the job that it's working on. So this works really well when you have to burst up for a short period of time, scale up your infrastructure, render some jobs. A better solution, if you're going to build infrastructure on the cloud that you're going to leave there, if you're going to have workstations, if you're going to have a team of artists around the world working with data that you want to use a partner solution such as Weka or Cumulo, and I have a slide for each here. And so Weka is a cloud-based file system that lets you build up a cluster of instances. And the way to think about this is a bit different, right? Because we talk to customers who have like a centralized storage, which is one server. Perhaps they have 10 Isilons, the Blue Arc or whatever. They have a whole bunch of infrastructure. And that's kind of what they use. And it doesn't matter how much work they do, because that's the finite resource that they have. When you look at something like Weka or Cumulo, you can build on demand your infrastructure. So with Weka, for example, it's been tested to do 7 gigabytes per second to a single instance. And so you could build a cluster on demand. You can even use spot instances for part of your cluster and shrink it back down at the end of the project. So this changes how you think about storage, because you can be in a position where, oh, I have 50 machines on-prem, I have 500, I have 2,000, I have 3,000, I have 10 Isilons, I have 20 Isilons, whatever you have on-prem, you have 20 petabytes, you know, the idea of 1 petabyte, you're feeding each machine a certain bandwidth because you're constrained. When you think about the elasticity of AWS and the cloud, you can completely change that mindset. So you can spin up the machines, but you can also spin up your storage, and you can spin it back down. Jason Fotter, who's going to come and speak up next, is the CTO of FuseFX. They use Cumulo. And I think he's going to talk a bit about how they use this in production. But one of his favorite things, and I'm going to steal his thunder right now, is he likes to say that his favorite thing is when he can turn it all off. It doesn't cost him any more money anymore. So if you had to buy a whole bunch of servers or infrastructure for that one project, it makes you change your mind, right? Like, and this is what happened with Tangent, is they had 2 feature film projects instead of 1. And they said yes to the second one because they knew they could scale to the cloud. So Cumulo, the advantage of Cumulo, it's a high-performance file system again. It's very easy, supports Windows and Linux. It's out of the box. It has a lot of management layers so that you can control it really well from the cloud. This also has on-prem file server so that you can synchronize the data within the Cumulo system. So I wanted to talk about workstations as well, but I'm out of time here. And this afternoon, we actually have a presentation on workstations by our own Bobo. And everybody needs their own Bobo. And he'll come up here later and talk about workstations. But first, I'm going to bring up Jason Fotter, CTO of FuseFX. And he's going to talk about running production with Deadline on AWS with Cumulo. Can you play it? Thanks. Can you play the reel? He brought a little teaser of what he's been working on. Thank you.
Thank you. It played smooth while we were testing it. I don't know what happened there, but you can check it out on our website if you want, FuseFX.com, and see some other reels up there too if you're interested. Thank you, Chris. I won't hold it against you for stealing my thunder, but I do love to say that. A little bit about FuseFX. We are an award-winning visual effects facility. We focus on episodic television visual effects. We have about 330 employees across 3 different offices in Los Angeles, New York, and Vancouver. And right now we're working on about 100 or so projects. Up on the screen there are some of the few that we're working on. And we're very proud of our Mr. Robot team this year with their Emmy nomination. So good luck to them. A little background and foundation of where a company like FuseFX is at in this industry. And I like to bring up this graphic because it shows the upward trend of television and what's happening. And this graph shows the number of original scripted TV series from 2009 to 2017. And you can see the upward trend here. We're towards the end of this year, 2018 should come out. And that graph is just continuing to go up and up and up. More content is being created. Obviously, people like Netflix, Amazon Studios, others are just generating a tremendous amount of content, which is exciting for us. But they're also doing it at 4K, and they're giving us more challenging visual effects that are just upping the bar every single day of what we can accomplish. And in television, we do it on a 2 to 3 week schedule. So it's really fast. We have to be super efficient and agile, and that is why we've looked to the cloud for our rendering needs to be able to help support those kinds of workflows and productions. To get right into it, this is our infrastructure design of how we do it. You can see here, there's the little, there it is. So our on-prem infrastructure, like Chris was talking about, local render farm. We have an Isilon 1 petabyte cluster on-prem. Obviously, we're Deadline customers. And we have a proprietary studio asset system, production system, business tracking system called Nucleus. This is at the core of what we do and how we do it, and allows us to be able to synchronize files to and from all locations, including the cloud. On the cloud, we run a Cumulo cluster underneath our Spot fleet of render nodes, and this is spun up on demand at varying levels. And that's what I'm going to get into here a little bit with this presentation, is really a focus to take more what Chris said on storage and how storage is so important in this infrastructure. Before the cloud, you would, in visual effects, you become aware very quickly that the render farm is the most critical piece of infrastructure that you have to design around. Massive amounts of compute, fast file system access, and you need lots of storage, especially now that we're rendering in 4K and beyond. So you would build a cluster, you would spec out a certain amount of storage, a certain amount of throughput that you thought you might need, and hope for the best in the coming years, that was going to be sufficient. And you'd have extra rack space just in case you needed to buy more, and that was kind of the model. But you'd get yourselves into situations where even that, with the render farm you had, was not enough. And especially on 2 to 3 week schedule, notes come in, changes happen, clients add shots. It gets very hairy, very tricky to funnel all that through a limited pipe. And so that's why we look at the cloud. And Chris talked about the infinite elasticity of what the cloud gives you. It's pretty easy now. You can set up an account and turn on 1,000 instances if you want to, or more. But you have to have good infrastructure underneath that render farm to get the work done. Visual effects is a file-based workflow still. All the applications we use expect a file system. And so you need these high-performance file systems underneath your either on-premise or cloud infrastructure to support those loads. This graph is a fun graph for me because it shows actual usage and there's a fun story behind it. This is last year in August and September of 2017. We were, as we get into August, September, that's our busiest season. That's the time where most television shows ramp up and they start production again, and then visual effects and all the work comes into our facility. So you can see here, this is our cloud usage in number of thousands of hours per day. And so August, just kind of rolling along on-premise infrastructure, working just fine. And we start to burst up a little bit, come back down, burst up, till we hit this date right here, 9/28, 9,000 plus usage hours in a single day. So the day before, Chris mentioned deliveries in his presentation. We were up against a massive delivery on the tick. And the night before, we had a plan. We're going to get all of our renders done, and then some stuff happened, and we actually had some issues with our on-premise render farm. So we came in the morning, and nothing was rendered. So I had the producers and supervisors of the show come into my office. Their eyes are really big, kind of scared look on their faces, like, what are we going to do, Jason? And we had been tracking, our cloud usage, and I had this target of 1,000 machines. We run 32 core instances, so that's about 32,000 cores. I said, we need to be able to run 1,000 machines within moments' notice because something is going to happen that is going to require us to do that. So this was that moment. So we turned it on, and in a matter of about 5 hours, we saved the night, we got all our deliveries done, and the client was happy. And so if I had to forklift 1,000 machines into my infrastructure, that would be impossible. I would not be able to do that. I just don't have the power, I don't have the cooling. Maybe I stick them outside with a generator. It's not going to happen. So storage lives underneath all of that. And so when I think about storage for the cloud, obviously storage comes down to 4 different overall metrics. Capacity, we all know what that is. IOPS, latency, and throughput. The IOPS are the biggest one for us. When you have multiple thousands of machines accessing a single file system at any one time, maybe they're reading 50 to 100 or 1,000 files, all writing multiple files, that's a lot of access on the storage. It's not always a lot of throughput. It doesn't always have to be real time on a render farm, but it's definitely IOPS intensive. And the challenge is that we don't always know when that load is going to spike. So we want cloud storage that gives us the ability to dial in these 3 variables at a moment's notice, really is the goal there. To be able to say, okay, we need to react now. Okay, maybe in the coming months, those 1,000 machines aren't going to be enough, and I'm going to have to run 5 or 10,000 machines. Amazon gives us the ability to do that, but I need a file system underneath that can support that. So that's what we're looking at. That's what we're building. That's what we're trying to accomplish with Cumulo, and just build a system that can be elastic infinitely to whatever capacity we might need. Here's a diagram of 3 different scenarios of possibilities, right? So these are your file systems. What I really want is something that's backed by S3 so that these become temporary in their need. If you need to spin up a file system on the cloud that supports 100K IOPS, 10 gigs a second is 100 terabytes, that's a substantial cost right there. And if you're going to persistently carry that over time, maybe if you need that all the time, then fine, you run like that. But if that job is only running for 5 hours, then I don't want to have to carry this cost and carry this load, unnecessarily. So if you can have a file system that can spin up in different variations like this to handle these types of render loads, and then you can turn them down, and then your data is on S3, or maybe it's on-prem, and then you deal with it like that. That's the goal for me, and that's what we're working on, and that's the future of this architecture, and what I see is something that's very, very powerful and will allow us to take on any workload. And okay, you need that done in 5 days, okay, and it's going to be a massive amounts of rendering. Yeah, we can do that. Oh, it's a little, I'm going to just do this. Sorry, the deck got a little messed up. So what's next? The challenge of syncing files, I put that at the top of the list. I mentioned in my earlier slide, Nucleus handles that for us. That still is a challenge, though, because if you have a massive data set that you need to transfer, we use our transfer mechanisms for our other locations. We have render farms in New York and Vancouver that we can leverage whenever we need to. The nice thing about that is those offices are smaller, but if they get into a situation where they need a lot of rendering done, we can offload that, those renders to LA or the cloud. But it still is a challenge to synchronize files, and it still is something that can create a bottleneck depending on your bandwidth and depending on the amount of data that you can synchronize. So that's pushing us into this idea of desktops in the cloud, and I know Bobo's going to show later on a presentation about that, but we're really excited about this. It's something that we really want to solve internally, and then it removes the challenge of syncing files, because now you are creating all your content in a cloud environment, and then it's already there. There's no synchronization necessary. Then you can just spin up the farm that you need to render that amount, spin up an appropriate size farm to render that job, and move on. The other thing that's exciting me about cloud is AI and machine learning. We've got our Nucleus database system with a lot of data in it, a lot of historical data that we want to be able to leverage with things like with machine learning. One of the cool things that I'm thinking about right now is predictive render load. So if you can take historical data on what was rendered and know, okay, I have this finite resource of on-premise infrastructure, analyze all the jobs that are on the farm right now, figure out your load for the night and what it's going to take to get that done by a certain amount of time. I like to say, Chris didn't steal my thunder on this one at least, is time is a variable now. Before, you had a finite amount of time and a finite amount of resources, and you just had to make it work. Maybe you drop your resolution on some renders, which is not ideal, call the client up, ask for a push on delivery, which is never fun. What the cloud is giving us is the ability to say, yeah, we can hit that target. We just need to run this certain size load to get that done. And so being able to predict that and being able to know, okay, tonight's render load is going to be this, and it's going to take this amount of resources, is something I'm really excited about doing, because it'll help us understand our process more and make even better informed decisions. And the whole idea of virtual infrastructure is really, really exciting. You know, in the beginning, I talked about on-prem needing to buy this massive physical cluster. Now this thing can be virtualized, and I can run a massive cluster for a short amount of time that I would have never been able to purchase locally, because it just would have been cost prohibitive, and it wouldn't have made sense, and now you're doing it and you're stuck with it. So when you virtualize these things, you now have the ability to do those kinds of things on an as-needed basis. And that's really exciting in visual effects, because things change on us all the time. Chris had a previous slide in another presentation we did together, and he shows this diagram of all these squiggly lines and all these things connected to everything in this iterative process of visual effects and what we do. And it really is true, and it's, you know, our process every single day of creating images and being able to respond to varying loads and you know, just be elastic in our choices is something that's really exciting. And then this idea of a global VFX company in the cloud, you know, there's a tremendous amount of talent all over the world. You know, at Fuse we have some of the best artists, but there's people doing really, really creative work all over the globe. And so if we can build an infrastructure that supports any artist anywhere, then we can leverage that talent, and we can use them either, you know, full-time, part-time, use their specialty. You know, some things we do are crowds, and those are highly specialized parts of visual effects that we don't do all the time. And so finding talent that is available that can get that work done, if we can expand globally and be able to attract that kind of talent, that will just allow us to do the oncoming work that's coming in the future. That's it. Thank you very much.